Hi, this is Miss Becky again. Today I'm going to be going over how to work on the section in geometry of IXL for Q6. And that's going to be finding the sine, cosine, and tangent values of the special right triangles that show up on the unit circle. And we've gone over that before. Just to remind you that rather than using X and Y, for the lengths of the on the x-axis and the height on the y-axis, we just simply use the cosine and the sine values that are show up on the unit circle. Um, Now we'll just jump right in. So I find it handy if you have this unit circle handy while you're working on IXL. So for the first one, they want us to find the sine of a 30-degree angle. So we pop over here to our unit circle. And this is the 30-degree angle right there. We said that sine is this one. This is sine. I can't do that. Oops, can't do that. Sine is this one right there, and that's just simply 1/2. So that would be 1/2. Easy peasy. Cosine. Let's do that in blue. Here's the cosine right there. Cosine is the square root of 3 over 2. Hopefully you can see that. And I'll put the answers here. It's a square root of 3 over 2. Now, IXL, make sure you pay attention to the directions. They want the answers in simplified, rationalized forms. That means your calculator, unless it has a program for figuring that out, is not going to do it. Okay, so moving right along. Tangent. Now, we know what is cosine and sine, but the tangent, which is right here, tangent is a ratio of sine over cosine. So we said the tangent is a little bit more work. It's going to be the sine, which is 1/2, divided by the cosine, which is the square root of 3 over 2. Now, what this really means, I'll do it the long way. What that really means is 1/2 divided by the square root of 3 over 2. These are just simply fractions. No big deal. If you remember from your fractions, we have to turn it into multiplication, and the reciprocal, I like to call it the reciprocal of the second one. Now, what we notice here is I find it easy to cancel these. Those cancel out if you know the canceling method. It just simply makes it easier because it reduces before multiplying. Now we have 1 time, well, actually, this turns into 1, this turns into 1. 1 times 1 is 1. 1 times the square root of 3 is the square root of 3. Now, you cannot have a radical number in the denominator. So what we need to do is rationalize it. So we will do that by multiplying it by itself. And what you do to the bottom, you've got to do to the top. What that gives us then, I'll write that down here. In the numerator, we have the square root of 3 over the square root of 3 times the square root of 3 makes 3. Okay, so that's our final answer. Write that here. So square root of 3 over 3. Just to show you the other way, rather than canceling out these 2's, if you don't know that way, you just simply multiply straight across. So that's going to be 2. And on the bottom, you're going to have 2 times the square root of 3. And you would still have to rationalize the denominator. That's going to be times that. Now, what ends up happening is the 2 divided by 2, they cancel out, they equal 1. So what that gives us then at the top is square root of 3 over 3. So same thing. All right, so for number two, we're moving right along. I just went ahead and took off this part of the unit circle because we're really only using this first quadrant right there because we're working with 30, 45, 60-degree angles. So number two, we're working with a 45-degree angle. We're looking for the sine of the 45-degree angle. So that's going to be this angle right there. And the sine is the square root of 2 over 2. Square root of 2 over 2. Now, if you remember those 45-degree triangles, both sides are the same. So that tells us that the cosine is also square root of 2 over 2. Now, for the trickier part, we need to figure out the tangent of the 45-degree angle, and that's going to be the sine, which we said is the square root of 2 over 2, over the cosine, which is also the square root of 2 over 2. And if you remember, this looks really crazy, but here we've got the exact same thing on the top as we do on the bottom. And if you remember, very simply, if you have anything, any fraction where the numerator and the denominator are the same, it simply equals 1. So you could have a million or whatever. So 5 over 5 equals 1. It works for this also. Same thing for the same thing equals 1. So our answer for that is just going to be 1. All right, now this is the other type of problem that you're going to see as your point score goes up. We know that we have the sine of a 60-degree angle. What color do I have? Red. Yeah, so we're working with a 60-degree angle. Okay, and we know that the sine is the opposite over the hypotenuse. But I'm not sure that's necessary, so we just took that off. Anyway, so you're going to see the problems like this, and we need to solve for x. And they need to be rationalized forms still. So first you want to get x isolated. You want x by itself. Now, when you have, this is really like a fraction over here. So it's a ratio. You've got this fraction equals another fraction. The easiest way to isolate x there would be, so if you've got this fraction here and it equals another fraction here, pretty much these guys, you can just move them this way, crossways. And these terms here, you can move like that. And I'll show you what I mean. And it's just a faster way of solving these problems. So we want to solve for x. So we want it up here. So I'm going to move x up there. And it needs to be alone, so I need to move this sine of 60 over here. So I'll put that there, and we'll leave the 5 up there. Now, this is isolated, so we can solve it. All right, I'll go this way. We have 5. The sine of a 60-degree angle will pop over here to our triangle. Sine is the square root of 3 over 2. So that's the square root of 3 over 2. Now we have a complex fraction again, and that simply means, choose another color, 5 times, I'm going to use the reciprocal, I'm going to flip it, and that one gives us 10, well, 10, sorry, divided by the square root of 3. Now, we do not want, this has to be rationalized, so we need to multiply that by itself to turn it into a 3, which then gives us, on the top, we have 10 times the square root of 3 and a barking dog over 3. So this is our final answer right there. Okay? Okay, so this next one looks a little bit different because the variable that we need to find is on the top of this numerator on that fraction. And again, step number one, we need that x isolated. We need it by itself. So what I can simply do is move the 2 over here, and then it's going to leave x by itself. Let me just show it to you like this. So if I've got if I'm going to get rid of this, x is being divided by 2, so I would multiply this side by 2 to get rid of it. So multiplying by 2 undoes this division by 2. They end up canceling out like this. And then, but what you do on one side, remember, you have to do on the other side. I multiplied this side by 2, so this side needs to be multiplied by 2 also. All right. Now, I'll just write it down here. So what that gives us is 2 times the cosine of a 45-degree angle equals x. We want to look up what is the value of a 45-degree angle. So we just simply go over here to our unit circle, and they're both the same. So the cosine is our x value, square root of 2 over 2. So that gives us 2 times, let's write it like that, square root of 2 over 2. And that's what x equals. So we'll simply multiply that. 2 times the square root of 2 gives us 2 times the square root of 2 over 2. And then these guys cancel out. 2 divided by 2. So 1 cancels out. So x equals square root of 2. And that is fine. Should be about it. That's really all the examples that you need. I'll throw one more up here if you want to finish filling in your notes, but I'm not going to waste time talking you through it. I'll just write it all out for you here. Okay. So I did example number 5. Um, so if you want to pause the video and just copy that down and work your way through it, you can see what I've done there. But you should be set to do that section. Until next time.